the previous video we have discussed about the derivation part of internal field, that is the expression for internal field for liquid and solid we have seen. Now the continuation of expression for internal field leads to the Clausius-Masati relation. Here in a Clausius-Masati relation, we are going to consider the polarizability, which means the electronic polarizability we are going to consider. So already we know the formula for dipole moment, that is dipole moment which is equal to mu into L. Here if it is a polarization, we can write the dipole moment, that is mu divided by N, and the unit volume is N. And after that the electronic polarizability can be written as mu, which is equal to alpha E into EA. This is what we have seen in the introductory part. So the same polarizability can be written as by using this same formula, because mu which is equal to, we know that alpha EA, you substitute this mu here in N. So what you will get then, dipole moment per unit volume, N into, instead of mu I am going to substitute alpha E into EA, that I got. So this dipole moment per unit volume is nothing but polarization P. So P which is equal to N into alpha E into EI. EI is an internal field, alpha E is a electronic polarizability. So EI which is equal to, from that EI alone I am going to keep it on left hand side, remaining part you just move to the right hand side, that is P, which is P divided by N into alpha E. So already we know that the P, that is polarization, can be written as epsilon into epsilon r minus 1 into E, where E is the applied field. So from that I am going to write only E, because for total internal field we need that applied field as well as the field of all the dipoles. So now E which is equal to P divided by epsilon naught into epsilon r minus 1. Now EI, we know that the EI formula for the Lorentz field, EI which is equal to E plus gamma into P divided by epsilon naught. For gamma is the internal field constant, already which we have discussed in the what is that, internal field derivation. So now what we have to do is, EI we know that P divided by N into alpha E, and E we know that P divided by alpha sigma naught into sigma r minus 1 plus gamma into P divided by epsilon. So everything you substitute in this equation, you will arrive this equation. So in that all the term, P is common, so take outside and cancel it. So 1 by N into alpha E and 1 by epsilon naught and 1 by epsilon r minus 1 plus gamma. So what the epsilon r minus 1, you just do in a LCM, you take it LCM. So what the value for gamma, already we know that that is 1 by 3, that also substitute. After that you take LCM, and LCM if you take means 3 plus epsilon r minus 1, 3 minus 1 plus 2, and again you will get this equation. So here 1 by epsilon naught, you take this epsilon naught into the left hand side, so epsilon naught divided by N into alpha E, which is equal to epsilon naught plus 2 divided by epsilon naught minus 1 into 3. So rearrange this equation to arrive the Clausius-Masati equation. So Clausius-Masati equation, all the epsilon naught value, epsilon naught is nothing but relative permittivity on one side, that's why epsilon naught minus 1 divided by epsilon naught plus 2, that 3 you can take it to the right hand side. So N alpha E divided by 3 epsilon naught. This is a formula which we have arrived from the internal field equation. This is called Clausius-Masati equation. So by using this equation, you will get many numericals. So in that, the epsilon naught term is a constant, and N is an unit volume, and alpha E is the electronic polarizability, and epsilon naught is the relative permittivity of permittivity of free space, and epsilon r is a relative permittivity. So everything, if you know the constant, easily we can find out the electric field or polarization or whatever it is for the requirement of the given problem. We can use this Clausius-Masati equation.